Good morning, students. Hope you have understood the concept of conic section with the video. So let us start the chapter conic sections today. Conic sections. So the conic sections or conics can be defined as the locus of a point which moves in a plane such that the ratio of its distance from a fixed point to its perpendicular distance from a fixed line is always constant is called a con or a conic section. So let S be the fixed point and L equals to 0 be a fixed straight line and P be any point in a plane and M be the projection of P on L, then the locus of P such that SP by PM is a constant is called a conic. It's called a conic. So this is the fixed point S, and this is a moving point in a plane, and this L equals to 0 is a fixed straight line. So this is the distance of P from the fixed point, and let M be the projection or normal or simply perpendicular of P on this L equals to 0. This is PM. So SP by PM, the ratio of SP by PM is always a constant, is called a conic. Here the fixed point S is called focus. Fixed line L is called the directrix. And the fixed constant denoted by E is called eccentricity. So the ratio is called the conic. So SP by PM is equals to a constant. That constant is called ratio is called the eccentricity. So if this E is equals to 1, then the conic is called a parabola. That means, so this is the fixed point and this is the fixed line. So let us suppose this to be P. It's this. So M is the perpendicular of P onto L equals to 0 fixed line. This is M. Then this is equals to this. When E is equals to 1, then SP by PM equals to 1. SP is equals to PM. That means its distance from a fixed point is equals to its distance from a fixed line. That is to say, and if E value is lying in between 0 and 1, then the conic is called an ellipse. The conic is called an ellipse. An ellipse. If E is greater than 1, then the conic is called a hyperbola. If E is equals to 0, then the conic is called a circle. Similarly, if E is tending to infinity, then the conic is called a pair of straight lines. A pair of straight lines. So, let S be H comma K and L AX plus BY plus C equals to 0, comma, let P X comma Y be any point in the plane and M is the perpendicular. M is the perpendicular of P on L equals to 0. Then, by the definition of a conic, SP by PM is equals to E. That means, so let S be the fixed point here and L equals to 0 is the fixed line and P is a point here. This is H comma K and this is X comma Y and this is M. So what is this L? AX plus BY plus C equals to 0. This is SP. Now, according to the definition, its distance from a fixed point, the ratio of its distance from a fixed point to its distance from a fixed line. That means SP by PM is equals to E. So what is SP? 2 points are there, distance formula. So otherwise SP is equals to cross multiplication EPM. Squaring on both sides, SP square equals to E square PM square. What is SP? The distance of 2 points. The distance between the 2 points. So square root of. So that is why I have squared here. Then I got X minus H whole square plus Y minus K whole square is equals to E square. What is PM? PM is the perpendicular distance of this P onto the line AX plus BY plus C equals to 0. Length of the perpendicular drawn from P X comma Y to this line is AX plus BY plus C by square root of A square plus B square. So PM square means this whole square and this square and root will be eliminated. Then let us see what will happen. If you expand here, x square plus y square minus 2hx minus 2ky plus h square plus k square. Okay, that means x square y square 2hx means x, 2ky means y plus h square plus k square, that means constant. Here if you square here, a plus b plus c whole square, a square plus b square plus c square, that means here x square y square, next constant square, next 2axby, that means xy quotient, yc cy constant y plus constant x. That means on simplification, So we are getting x square, y square, x, y. So on simplifying the above equation, we will get a second degree non-homogeneous equation. So let us consider that second degree non-homogeneous equation to be ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equals to 0. So this is that means the equation of a conic we will get in terms of x and y, which is a second degree non-homogeneous equation. So just now we have discussed that the SP by PM is equals to E. After the expansion of it and simplifying, we will arrive to a general equation. We will arrive to a second degree non-homogeneous equation ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equals to 0. Last year we have learned about this delta. Delta is equals to ABC plus 2FGH minus AF square minus BG square minus CH square. If this delta, actually we can classify this into two categories. Delta is equals to 0, delta not equals to 0. Delta equals to 0, in pair of straight lines we have learnt this. And if delta not equals to 0, we are going to learn about these things. Okay. So earlier, if on the basis of E, if E is greater than 1, less than 1, is equals to 0, E is tending to infinity, etc. So on the basis of that, actually the behavior of a conic we have discussed. And now, based on the second degree non-homogeneous equation, if this delta is equals to 0, then this S is called degenerate coin. That we have discussed this in the video. And if delta not equals to 0, so in these two categories we can classify. If h square equals to AB, S represents a pair of parallel lines. H square is greater than AB. This we have discussed, and actually based on these problems also we have solved in the first year. Pair of intersecting lines. H square is less than AB. Pair of imaginary lines intersecting at a real point. If delta not equals to 0, in this, if h is equals to 0, a is equals to b. Simply, h is equals to 0 if you substitute, then quotient of xy is missing and quotient of x square is equals to quotient of y square. Both are, b is also a, for example. And a if you take common, then x square plus y square plus 2gx plus 2fy plus c equals to 0. That is the general equation of a circle. Otherwise, ax square plus ay square plus 2gx plus 2fy plus c equals to 0 also, that is the circle equation. If a is equals to b is equals to 1, then that is the general equation of a circle. That we have learned with this. And if h square equals to ab, then this second degree non-homogeneous equation will convert into a parabola. And if h square is less than ab, then s represents an ellipse. H square is greater than AB, then S represents a hyperbola. And H square greater than AB and A plus B not is equals to 0, then S represents a rectangular hyperbola. Before we begin into the actual session, we shall be discussing the various terminologies of this conic sections. First, principal axis. Principal axis, the straight line which is passing through the the fixed point. What is fixed point? Focus. And perpendicular to the fixed line. What is fixed line? Directrix is called a principal axis is called principal axis. That means, so this is S and this is L equals to 0. Passing through a straight line passing through the fixed point and perpendicular to the fixed line. Passing through the fixed point, passing through the focus and perpendicular to the fixed line, which is the directrix. So therefore this line is called the principal axis. Next, chord. The line joining any two points of a conic is called a chord. So for example, because the circle chapter is already over, let us see this. So this is a circle, this is a conic, for example. So a line passing through any 2 points of a conic. Here this conic, for example, is a circle. So the line joining any 2 points of a conic is called a chord. Focal chord. The chord passing through the focus is called focal chord. That is, this is the focus and a line passing through the focus is called a focal chord. Double ordinate. The chord which is perpendicular to the directrix is called double ordinate. That means, if you take the situation here, so this is fixed line and equals to 0. This is fixed point, focus. So this is the straight line. This is the straight line. This is the straight line passing through the focus and perpendicular to the directrix. And now this line which is perpendicular to the principal axis is called the double ordinate. And latus rectum. The double ordinate passing through the focus is called double ordinate passing through the focus is called latus rectum. That means this is the fixed point and this is a fixed line. So this is a straight line which is called the principal axis, because this is the straight line passing through the focus and perpendicular to the fixed line. So this is the principal axis, and this line not only passing through the focus but also it is perpendicular to the principal axis. So whenever it is a perpendicular, it is a double ordinate. Whenever it is perpendicular, this line is perpendicular to the principal axis, it is double ordinate. Now this double ordinate is passing through the focus. This line is called the latus rectum. In another way, focal chord. Focal chord means passing through the focus. Focal chord which is perpendicular to the axis. is called latus rectum. Latus rectum. So this is, so if it is, so what is chord? The chord, the line joining of the 2 points of the chord of the conic is called the chord. That chord is passing through the focal chord. This focal chord is perpendicular to the principal axis. So focal chord perpendicular to the principal axis is equals to the double ordinate passing through the focus. Both are same, which is the latus rectum. And center. Center. The point which bisects every chord of a conic, the point which bisects every chord of a conic passing through it is called center. So for example, so this is a conic, for example, and this is the center. Then for example, this chord, if I take this point C bisects the chord equally. Not only that, if you take this, for example, this point C bisects this chord into equal parts. So that point is said to be what? It's a center.